Okay.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. You're done?
Done. Hey guys, hope you guys are all doing well. I'm going to be going over your types of natural selection. I know we talked about the steps of natural selection before, but there are 3 different types. So just to show you what I'm looking at on the calendar, we're going over April 20th, the types of natural selection. So this piece here. There is an assignment that goes along with this, so you should have that shared with you. And what that looks like is this document here. I know these are PDF files that I'm sharing with you, so sometimes I don't know that you have the ability to edit these. So if you're typing these out separately, that's fine. They're all Word documents, and if you even wanted to say for like these multiple choice questions, just numbering and then telling me whatever your selection was, that's fine too. There is a graphing section, so I will want to see pictures of that. So make sure that you're doing that as well. You don't necessarily need graph paper. I do have some here if you can print this out, that'd be cool. So that's the assignment that you should be able to do after you've viewed this video. I will show you a PowerPoint that will also help you with this. This is also shared with you. Ooh, let me move me. Maybe if I'm over here. As I said, there's going to be 3 different types of natural selection, and this PowerPoint should walk you through that, but just so you have some idea of what you're looking at, this first type is considered directional. And so what's going to be happening is that we're dealing with bell curves here. And so any population's traits can be graphed on a bell curve. So for example, if we were all back in class, what I would have you guys do is you would all stand up out of your desks and we would all put ourselves in order of height. I'd have you guys come up in the front of the room, put all the tallest people on one side and all the shortest people on the other. And what we would find is that if we numbered how many tall people we have, how many average people we have, and how many short people we have, it would make this bell curve if we were to graph it. And what I mean by that is most people would fall into this average section, and we would only have a handful or a couple extremes where we'd have really, really short people and really, really tall people, but there wouldn't be as many of them. Most of us would fall in the center of this bell curve. So that's what this is showing, is a distribution of traits. And so once you start talking about the different types of natural selection, if it's considered a directional natural selection, what that means is there's going to be a shift in that bell curve to one side. And so in this case, if we're sticking with our height example, and I said that all my tall people were represented here, what this is saying is that over time, for whatever reason, being tall was beneficial. And if you remember from our last slides, if you have beneficial traits, that means that you survive to reproduce, and then your children would have those beneficial traits as well. So in this case, if it was beneficial in your environment to be tall, what we would see over time is more and more people would be tall, and so there would be a shift in that bell curve. So again, that dotted line is showing you the original population, and the second solid line is showing you that shift. The example I'm giving you here, I'm just labeling small, medium, large to give you an idea of traits. And here's what I'm referring to. These are horses. What they've seen is, looking at our fossil record, is that horses used to be really, really tiny. So their body size was very small. But over time, the larger of these animals survived more often and had more offspring. And so over time, they became larger. And still, even more time has gone by, and now horses are even larger. And so what you're seeing here is a directional change in size. And that's just one example. But again, that bell curve is looking at different traits. And then a directional change will say that those traits are going to move in one direction over time. So in words, a directional shift means that one extreme trait is more successful than the rest, and they'll become more frequent in a population because those are the organisms that will survive and reproduce. Our next type of natural selection is called stabilizing. So again, we're looking at that bell curve. And in this case, instead of an extreme, so before we were down here and we said that it was good to be tall, in this case, it's good to be average. And so you're going to see a spike in the population from those average traits. So it's not good to be super short and it's not good to be super tall. It's good to be right in the middle. And so an example of this, again, I'm just putting some traits on the bottom, would be in bird wings. I couldn't find pictures of this, so I drew things in for you. But if you were to think about it, if a bird, in comparison to its body, had really tiny wings, probably not going to be very successful. And if a bird, in comparison to its body, had really, really large wings, also going to be cumbersome and in the way, it would be good to be right in the middle. And so we're going to see more and more of that type of bird out there. Excuse the goofy pictures, but that's what that is. So, and then in words, what a stabilizing natural selection type is when that average trait, or being in the center of the bell curve, is most successful, and we'll see more of those traits becoming more and more frequent as time goes on in a population. And then your last type is disruptive. And so again, this is our original population, and in a disruptive, it's not good to be average, and it's not good to be one extreme, it's good to be either extreme. So it's good to be either really short or really tall. But if you were average, you were not successful. And so what this could look like, I have colors here. So I have white, gray, and red, and I'm showing the fox. This might not be the greatest example, but if you were to think about the fox, if it were living in an area that had snow, or a seasonal time where there is snow, a white fox could blend in during that time. And then if you had a orange coat, you could blend in the summer or the fall months. However, if you had this dark coat, you don't fit in the summer months and you don't fit in the winter months, and there aren't areas that fall where they have always a black background. And so it might not be good to be this type of fox. Now, the reason this isn't the greatest example is because all of these fox do exist and all of these fox do survive, and some of them even change their coats. What you want to know about this disruptive type is when that average, so in this case I said gray was the average between white and red, was not successful, but being extreme, so being either white or red, was good. So both extreme traits are successful and they become more frequent in a population. Oftentimes, disruptive natural selection will lead to two different types of species, or at least two different subspecies. So that is, think of the foxes in that situation. This next part of the PowerPoint talks about other types of natural selection. Most organisms will fall into what I said, disruptive, stabilizing, and directional. However, that doesn't account for everything. There's still something called sexual selection. And what this means is that these traits are driven by one of two different things. Either females choosing desirable traits, or females choosing males that can defend them. So it will come to either being showy, like the peacock, so females are attracted to all the flashiness, or females choosing being able to be protected, so something like a moose with these antlers. And the reason these particular traits are attributed to being sexual selection is there is no good reason other than being attractive to another mate for a peacock to have this obnoxious tail and these crazy colors, just like there is no good reason for a moose to have these huge horns and run through the woods with them. This is purely based on sexual selection, and so this has to do with them being able to find mates and nothing else. So with sexual selection, it's about females choosing what type of traits they want. And then finally, there is artificial selection, in which case humans are choosing what is desirable. And so that's where we get things like, if you look at our crops of corn, they used to be very, very small. The ears of corn were very small, but we wanted more corn to eat. And so over time, we were choosing those larger ears of corn. We forced directional selection to make the corn that we have now. Or you can look at dog breeds. Each and every one of these breeds was selected for, their traits were selected for by people. It could be things about size, it could be things about being territorial, or if they shed or not. But we chose those traits for them, and we bred it into them. There are some videos here for you to watch. These are not my videos. These are other videos that I would watch in class about sexual selection and other parts of natural selection. So I encourage you to watch these. They're not very long. And then the definitions for natural selection and artificial selection are here. Basically, natural selection is just a series of generations and generations of organisms trying to best fit in their environment. And so nature is picking what traits are successful. And then artificial selection is when humans pick what's successful. So again, that's where I was talking about the corn and that humans wanted to eat more. So we made larger ears of corn. Humans wanted our dogs to look this way. So we made them look that way. So hopefully this helps you guys with this. The biggest pieces here are those different types of natural selection. But based on this, you should be able to finish that worksheet. But as always, if you have any questions, please be emailing me. Have a good day.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science.